Hi students, it is the start of week 9 and this is the preview video for week 9. Got a few important things to talk to you about. First of all, this is real important. The drop deadline for this class, if you want to receive a W, which is a withdrawal while passing, I think. Well, maybe that's not BYU Idaho, that's another school. Anyway, March 9th or March 2nd is the deadline to drop to receive a W for your grade. If you are still enrolled at midnight between March 2nd and March 3rd, then you will receive whatever grade you have earned. So what does this mean to you? Well, if you're even close to being at risk of maybe not passing this class and you don't want that non-passing grade on your transcript, then you should consider whether it's time to drop the class. You know, maybe things haven't worked out this semester as well as you thought they would as far as timing goes, and unexpected things came up or whatever. There's no real shame in dropping a class. You don't get your money back, but if you are worried about having a non-passing grade on your transcript, you should think about that. If you're not even close to not passing the class, I wouldn't worry about that at all. Okay, that's the first thing. Second thing is we're starting a new section this week. We're starting a section on categorical data. This section is quite small. We have a total of, I believe, it's either 4 or 5 lessons before the next exam. Let's see. So we have week 9. We have 2 lessons week 9. I don't remember what numbers we're on. I think we're on 16, 17. Week 10 is 18 and 19. And I think 19 might be the review. And then week 11 is the exam. So the next exam comes up pretty quick. I think it opens up on March 13th. And that's just a little more than 2 weeks from now. So if it's felt like it's been going fast in the past to you, which it has been, we're going to ratchet up the speed just a little bit here, and got something coming up real quick. Anyway, that's the bad news. Good news is this section is really, really, really easy. It's on categorical response variables. So far, we have talked exclusively about quantitative response variables, where you're measuring something. You're measuring somebody's blood glucose level, or you're weighing babies, or you're measuring the lengths, or how tall somebody is in the morning versus in the evening. Excuse me, something like that. Anyway, now all the responses are yes, no, pass, fail. What else could they be? Maybe if it's a political election, you know, which party do you affiliate with, or which party are you going to vote for? Different things like that. But, you know, what's your favorite color, or what's your favorite kind of car? Talking about things where the response variable is categorical, and those require a little bit of different analysis. Now, this is the weird part. I've harped all semester long about how important it is to get good at SPSS and use SPSS for everything you're doing. So we're going to take a little time out from that right now, and we're going to start using Excel to do our categorical data analysis. And there are 2 reasons. Well, one main reason for this. SPSS will do it, but it is confusing and complicated and just not very user-friendly. So as a department, this is a decision that was made long before I started working at BYU Idaho, but as a department, decision was made that a categorical data analysis spreadsheet would be put together. So that should be available to you. I don't know exactly where the link is, but I think just to be safe, I will send you a link. I want to show you what that looks like and kind of give you an example of how it's going to work. So let me share my screen and then pull it up right here. Okay, so this is what it's called on my PC, categorical data analysis. Then it's got HAT 27 March 15. It should have 4 tabs. Should say 1 proportion, 2 proportions, chi-square, and version. There are several versions of this floating around. So if you pull up the version tab, and if it doesn't say last updated 27th of March 2015, you're not working with the right version. So you need to get the different version. That's the one you want, March 27th of 2015. Okay. I want to show you really quickly how this works. I want to walk through each of these very quickly. Here's the 1 proportion. The 1 sample z-test for proportion is what it's labeled. This is a situation where somebody says, hey, by the way, historically, the number of people who don't like potato bugs is 38%, just making stuff up now, obviously. And you want to conduct a study to see if that percentage is the same or not. So when I say something like that, like historically or the baseline or something like that, What I'm talking about is that's the population proportion. Okay, we're not doing population means and standard deviations anymore. We're doing population proportions. So I'm going to take a sample. I'm going to talk to 350 of my closest and dearest friends. That's kind of a poke at you guys who have thousands of Facebook friends and you don't know who most of them are. Anyway, so 350 friends. What do? I go to each one of these 350 friends and I say, hey, do you like potato bugs or not? And most of them are going to say, I don't even know what a potato bug is because they didn't grow up in Utah. Anyway, you explain that to them and they say, oh yeah, I like potato bugs or I don't like potato bugs. So you do that for all 350. So suppose you ask 350 people and you've got yes or no answers from all 350 of them. And maybe 180 of them say, yes, I do like potato bugs. So here's the way this works. So your N is the sample size. So in that case, this keyboard, that's going to be 350. My X is the number of responses that were aligned with my null hypothesis. And I'm saying that the population that likes potato bugs is 38%. So my yeses were 180 out of 350. My null hypothesis was 38%, or in decimal form, that's 0.38. And I want a 95% confidence interval. And my alternative hypothesis, whoops, I think I have to put 0.99, 0.95. Paying close enough attention, let's see how that goes. My type of hypothesis, the options here are greater than, less than, or not equal to. So all I care about is whether it's changed or not. So I'm going to say not equal to is my alternative. Okay, I punch that in. And I have to fill in the blue spaces. That's all I have to fill in. And I get all these other bits of information here. And I'm not going to explain what they all are, but you'll notice down here at the bottom, my z-score is 5.176. My p-value associated with that z-score is 0. My confidence interval for the true proportion is between 0.462 and 0.567. You'll notice my sample proportion, we call that p-hat. That's this thing right here, 0.514. And that's simply X divided by N. 180 over 350 is 0.514. So my confidence interval on p-hat is 0.462 to 0.567. So you'll notice those are equally spread around 0.514. Anyway, that is the one sample z-test. That's the first lesson you're going to get into. Two proportions, on the other hand, is a little bit different. This time instead, excuse me, instead of saying, hey, here's my standard and here's what I want to compare it to, you're saying, I've got these two groups. I wonder if they equally like stuff. Okay, so let's just take the obvious example. Let's go back to the potato bug example. Let's do, men and women. Do men and women like potato bugs at an equal rate? So out of those 350 friends I have, well, 170 of them are men. So this X1 and N1 will be the men. And I'm going to say 52 out of 170 men like potato bugs. So if 170 of them are men, 180 of them are women, and 180 is my N2, and my X2 will change that to be, we'll say 59. Okay, so in other words, 52 out of 170 men like potato bugs, 59 out of 180 women like potato bugs. My confidence level is 0.95. My hypothesis test is, again, this should be in blue, so it's not. But anyway, you need to set that. Type of test is my alternative hypothesis that the proportion of men who like potato bugs is greater than the proportion of women? Is it that the proportion of men is less than the proportion of women? Or is it that they're simply not equal? One of those three. So again, you've got the same sorts of alternative hypotheses going on there. So I select that, I hit enter, and I've got all my information shown here. So again, requirements, talk about that when the lesson comes along, so I don't have to worry about it now. Here are my p-hat values. 0.306 or 30.6 for the men, 0.328 or 32.8 for the women. I have standard deviations of the confidence interval, standard deviation of the hypothesis test. The text will talk about that stuff. We'll skip that. Come down here to the bottom box. It's the two proportion z-test. The null hypothesis is that P1 equals P2, or proportion 1 equals proportion 2. My z-score, negative 0.44. My p-value associated with that z-score is 0.66. This is big. I failed to reject. The confidence interval for the difference in proportions, notice how that's worded, confidence interval for P1 minus P2, and this is the confidence interval. So Think about this. Why am I doing a confidence interval for P1 minus P2? Well, if my null hypothesis is that they're the same, as you can see right here in this box right here, then my hypothesized difference, P1 minus P2, should be 0. Because if the proportions are the same, if I subtract one from the other, it should be 0. So this gives you a confidence interval on that difference of proportions. Okay, so that's the one proportion test, the two proportion test. This third box here is a chi-square test. And this happens anytime you've got more than two, I'm going to just call them rows, more than 2 rows and more than 2 columns of data. For example, let's suppose I've got, okay, 2 different rows. I'll say we'll do the men and women example, but it could be many, many different things, you know. But row 1 is men, row 2 is women. Then column 1, 2, 3, 4, and 5, and 6, and this can go on as large as you want it to make it. This table only handles 6 by 6. But let's suppose I wanted to determine which is my favorite work day of the week. Stupid question, I realize that. But let's just go with it for a minute. So column 1 will be Monday, 2 will be Tuesday, 3 will be Wednesday, 4 will be Thursday, 5 will be Friday. So for the men, I've done my surveying. I found that 5 men like Monday the best. 18 men like Tuesday the best. Don't know why. 3 men like, let's not do numbers that small. Okay, so let's say 32 men like Wednesday the best. 76 men like Thursday the best, and 158 men like Friday the best. If they're working, you can see why that would be. On the other hand, let's suppose you've got women. Let's suppose a large proportion of these women work in the home. So Monday's the first day that everybody goes to school and they got the house themselves, and they can get things done that they want to get done rather than have to worry about who's fighting with who or who bruised their elbow or whatever. So maybe for these women, maybe Monday's the favorite day. So I've got 312 women that like Monday the best, and then I've got, whatever. I've got some women these other days. I'm just plugging numbers in here. It doesn't really matter. Okay. So the null hypothesis for this scenario is that the columns are independent of the rows. So what would be the practical interpretation of that on the problem we just did? We'd be saying who likes what days better does not depend on whether you're a man or a woman. The alternative hypothesis is there's some dependence there, that this actually depends on whether you're a man or whether you're a woman. The test statistic here is a chi-square. That's what this word is up here. It's chi, it's not chi. So it's called a chi-square test. The test statistic is a chi-square test statistic. Degrees of freedom here are 4. You find the degrees of freedom by saying number of rows minus 1. So I got 2 rows minus 1, that's 1. Times the number of columns minus 1. I have 5 columns. So 5 minus 1 is 4. So I've got 4 degrees of freedom, or 4 times 1 is 4 degrees of freedom. My p-value here is 0. We reject the null hypothesis. All this other stuff down here you will learn about in the chapter. But don't use SPSS to do this stuff. It's so easy to do using this categorical data analysis spreadsheet. Okay, enough of that. One more very important thing I want to talk about is the group project. It is upon us. The group project to design the study is due by March 4th, which is this coming Saturday. The way this design the study happens is you get together as a group, you design a study, and then you turn in one design for the whole group. I don't want everybody in the group turning in their own design. You all agree, you figure out who the main writer is for the design, and that person turns in the design. That doesn't mean they do all the work. That means they're just the bookkeeper there and writing all the information down. You need to list who's in your group. You need to decide who's going to do the main steps. And for every step except for step 2, there is only one submission for the entire group. If I get 2 submissions for your group, that is a clear sign to me that you're not paying attention to the directions. Okay, so for every step except for 1, I only want 1 submission for the group. On step 2, when you're collecting the data. Everybody has to collect and submit their own data. You don't submit the data for your whole group. You go and you guys all decide what you're going to do. Everybody goes and collects their own data, and then you each bring the data back to me and submit that. Okay, there's a grading rubric that's designed to study. Let me put it this way. I probably reject well over 90% of the designs that are handed into me. Number one, because quite often they have a lot of information missing, anywhere from a little bit to a lot of information missing. And number two is that the design, in my opinion, is the most important part, not the easiest part. It's the most important part. Because if your design is good, then the rest of the study just kind of falls together. You have to hardly do any work at all because you've already lined out everything that needs to be done. On the other hand, if your design is bad, you'll start your study, you'll collect data, you'll start to do analysis, and then you'll realize, oh, we didn't even really collect the data we wanted to collect in order to answer the questions we're trying to answer. And so you end up with a really bad design. I would rather just skip that and not let people turn in bad designs and then just say, see, told you so after the fact. I would rather you have a good design up front. So some of you are going to get a little frustrated with me because I will reject your design and say, look, I think you need to beef up this section, this section, this section, and do this over here. And I don't agree with you on sections 1, 2, and 3 or something like that. So you might have to, sometimes people have to submit this as many as 4 times, but I'm going to make you keep submitting it until you get it right because I want it to be right. All right. There are some examples of what to do. I would highly recommend you not choose one of these examples. But here's what I think you should do. Find something you're kind of interested in. You probably as a group won't find anything you're all interested in, and that's okay. But find something you're somewhat interested in. And I'm telling you, there is so much opportunity to go to the internet and just collect data from the internet. So that's certainly an option. Grocery stores are filled with data. There's data on pricing. There's data on, buying a box of cereal with marshmallows in it and sampling a cup and then counting how many marshmallows are in the cup. Just stuff like that. Just be creative. Think about things like that, and come up with something that is something you're interested in. We're not trying to cure cancer here. We're not trying to solve world hunger. This is just the purpose of this is to get you to understand the steps involved with running an experiment. Okay, what else do I want to say without making this hugely difficult? Oh, there are a couple different things. Some of you have started to work on those research questions a little bit, and maybe you know a little bit about this, but some of these questions, you'll read them and you'll think, what is he even talking about? Like number 3, for instance, what is your experimental unit? Okay, let's go back to the cereal example I was giving just a second ago with marshmallows. Your experimental unit in that case was, I'm trying to determine if let's suppose my null hypothesis is something like, in a cup of Lucky Charms cereal, the average number of marshmallows in a single cup is 112. So my null hypothesis is that mu equals 112. My experimental unit in that situation would be a single cup of Lucky Charms cereal. It wouldn't be a single piece of cereal. It wouldn't be a box of cereal. It wouldn't be a grocery store. It wouldn't be Lucky Charms. I need to think of what it is that I'm actually going to be measuring, and then what is the entity from which I will measure and collect one single piece of data. Okay, so that doesn't make sense to you, please call me, because I can't even begin to explain to you the sorts of responses I get for this. What is your experimental unit question? If you have questions about it, call me, please. Okay. One other comment I want to make. Number 9, describe in specific detail how your group will collect the data using the sampling method stated in question in step 8. Also, what sample size are you planning to obtain per population? Okay. This is another area where I have a little bit of a pet peeve about. I'm shocked at how many college students will turn in a sentence, or maybe 2 sentences. 2 sentences, that is not specific detail. I want to know details. I want you to do this so well. I want you to describe your study so well that a reasonably intelligent adult person who has never taken a statistics class would basically be able to exactly duplicate your study. If they can't do that, or if there's questions, or if it seems weird, here's a test. Get done with this step, give it to your spouse, your friend, your parents, give it to somebody and say, hey, read this and tell me if you think you would be able to do what I'm going to do. And if they're walking through and they say, well, I don't get this part, what am I supposed to hear? And you say, oh, well, that means you go to the store and get that. If you're having to tell them that, you haven't got enough detail in your description. So this has to be very, very detailed. Boy, if it's less than 3 pretty fully developed paragraphs, I'm going to be skeptical that you actually have enough detail. Okay. Another really important part about the design the study. Question 11 says, will your project involve human subjects, yes or no? And will you be conducting a survey, yes or no? Everybody wants to do surveys. They're easy. You basically go and talk to people. However, it puts the university at a ton of risk when you start to do surveys, because when you go out and start talking to people, whether you believe it or not, or whether you know it or not, you are representing yourself as a representative of the university. So if you say things or do things or something happens, all of a sudden the university has some liability, and they just want to avoid that at all costs. Somebody is coming over to answer your question. They trip on a block on the sidewalk as they're approaching you. They fall down, they break an arm, they get some infection, and they die. And their family says, wow, that person was doing a survey for BYU Idaho. Those guys have a ton of money. I'm going to sue them. And they'll win, probably. So the university is just trying to avoid that at all costs. If you demand to do something involving human subjects or conducting a survey, there's a whole bunch of extra questions you have to answer. And then you have to come down and you have to submit your survey to, I'm trying to think what it's called, the Human Subjects Committee at the university. It's going to add days to your project. It's going to be a pain. If you submit it and they don't accept it the first time, you're going to have to resubmit it. My recommendation to you is that you not do a survey. Okay, now some of you are thinking, well, yeah, I've got Facebook friends. I could just do a survey with those guys. Nope, same category. That's a survey, and you're going to have to get the Human Subjects Committee to buy off on it. It's painful. I would recommend you not do it that way. Think of another project. If you can't think of a project to do, and you have some ideas, but they all seem to be surveys, call me. We'll talk about it for 10 minutes. Maybe I can lead you on to something else. Okay. Enough of that. Hope I've hit on the high points there. Anyway, this is due, the first draft is due by Saturday. Now, excuse me, the collect the data portion, which is step 2 in the project, is not due until 2 weeks after the 4th. I believe it's due on, or that would be the 18th of March. The reason it's 2 weeks away is because that gives you some time to submit the first draft, have me look at it, have me critique it, give it back to you, and then you'll have time to do a rewrite or 2, or maybe even 3 if you have to. So I'm not saying, oh, you got plenty of time, let's just go ahead and drag this out further. That's not what I'm saying. What I'm saying is you do have time that if you get your survey, if you give me your survey on, or your design on Saturday, and I grade it on Monday, and you don't look at it till Tuesday, there's no need to be in a panic that, oh, no, I got to hurry and get this done because I got to collect the data that's coming up due pretty quick. You have a little bit of time. I would recommend you get it done as quickly as possible. In fact, if you submit your design early this week, I will do everything in my power. Not sure what this week looks like for me. I will do everything in my power to respond to you as quickly as I can, hopefully within 24 hours of you submitting it. Okay, so I think that's all I want to say this week. Hang in there. We're more than halfway done. We're on the downhill side of this, so you've done great so far. If you have any questions, I know some of you want to review exam stuff. That's great. Let's get together. Give me a call, and we'll set an appointment to do that. Oh, one more thing I did want to tell you. There's a mid-semester survey in there somewhere. I'm not sure exactly where it is. Some of you have filled it out. Some of you have not. It's not required, but there are points attached to it. So if you don't do it, you won't get those points. So please get that done. I'm not sure exactly what the due date is. And if it's passed already, I'll extend it. I'll have to go check and see if it's already passed. But like I say, it is a graded assignment, so you're probably going to want to do that. All right. Have a great week. We will talk to you later. Thanks. Bye-bye.